G'day team, welcome back to another video. Today we're going to be looking at chapter 2A.3 in the Hazy 11 Methods textbook, and it's about using the quadratic formula to find the roots of quadratic equations, okay? So today I'm going to go through what the quadratic formula is, a proof of where it comes from, and then how to use that in a question. So if we have a general quadratic, ax squared plus bx plus c, which is equal to 0 for all a not equal to 0, then our roots x, so our roots of our equation, our x will equal negative b plus or minus the square root of b squared, take 4ac all over 2a. Now this is a very convoluted looking formula, and it's one of those things that we sort of take for granted sometimes in maths. We just kind of use it and don't really realize where it comes from or the meaning behind it. So what I'm going to do, I'm going to run through a proof with you of how to actually come up with this formula, okay? So we're going to take our general quadratic, ax squared plus bx plus c equals 0. The first thing we want to do, we want to get that x squared term by itself. So what we're going to do, we're going to divide every term by a, okay? So what that's going to get us, we're going to have ax squared over a here, so the a's just cancel off. Then we've got, so we're left with x squared there, plus bx divided by a, plus c divided by a equals 0 divided by a, but 0 divided by anything is 0. So we don't need to write that divided by a in. The next step, I'm going to take that constant coefficient, that constant term, over to the right hand side. So we're going to take away c divided by a from both sides. So that will create a 0 on this side, and we're left with negative c divided by a on the right hand side. The next step is we're going to be completing the square. So we've done a bit of work in a previous chapter, all right? So remember, completing the square, we need to add the coefficient of the x term divided by 2 all squared. So because our coefficient is b on a, we have b on a, okay? And then we've multiplied that by 1 on 2, essentially, okay? So the coefficient of x, divided by 2 is like timesing by a half. When we multiply fractions, we just multiply the numerators together and the denominators together. All right, that's why it's b onto a. So we're squaring that term, and then we're going to add it to both sides, okay? So you can see we have 1 over on the left-hand side and 1 on that right-hand side, okay? Now, we've done a few steps in one here. So on the left-hand side, if we're looking up here, we have our quadratic in the form a squared plus 2ab plus b squared, okay? So we can take a plus b all squared, and we've factorized that left-hand side. On the right-hand side, we've done a few different algebraic tricks, okay? So what we've done, we've got this square here being distributed to the numerator and the denominator here to get b squared and 4a. Now, when we're adding or subtracting fractions, we want a common denominator. Okay, so I'm going to multiply this term, top and bottom, okay, by 4a. All right, so that gives us a 4a squared on the bottom and a 4ac on top. And then all we're doing is adding them together, and I've just put this term on the right-hand side so that negative sign is in the middle. If you're still not sure about that, write it out yourself and slowly solve and simplify. You will see that it comes out to be b squared, take 4ac all over 4a squared. So because we want x by itself, we're going to take the square root of both sides. So the square root of a squared number is just that number. Just remember, we need to take into account both the positive and the negative solutions, okay? Negative 2 squared is 4, 2 squared is 4. So they both give the same solution. So we need to take into account both. Now, what we have on this side here, okay, so remember with surds, okay, we can write this as the square root of b squared take 4ac divided by the square root of 4a squared. All right, we can split that surd up. The square root of 4a squared is just 2a, and the top doesn't change. I have also subtracted b on 2a from both sides to get x by itself. And again, just like before, we have a common denominator, so all we need to do is add or subtract the two terms together. So finally we're left with x equals negative b plus or minus the square root of b squared take 4ac all over 2a. And that is our quadratic formula, okay? So there's the entire proof there. Make sure you just keep getting your head around that, making sure you understand where it comes from and the processes used. So an example of actually using the quadratic formula. So you will see a question that looks like this: solve for x, or solve for the roots if 3x squared plus 7x plus 3 equals 0. So you'll be given a quadratic equal to 0. I like to label my a, b, and c. That way I know exactly what gets inputted where. So all we're doing is substituting a, b, and c everywhere we see it into our quadratic formula. So negative b plus or minus b squared take 4 times a times c all over 2 times a. All right, and we're just going to slowly solve this. So negative 7 plus or minus 7 squared is 49. 4 times 3 is 36, and we've got the 1 negative sign left there. And 2 times 3 is 6 as well. All right, solving inside that surd, so 49 take 36 is 13. So we're left with negative 7 plus or minus the square root of 13 over 6. And what I want you guys to start doing is writing our rational numbers separate to our irrational numbers, okay? So x equals negative 7 on 6 plus the square root of 13 on 6, so that's one root, and negative 7 on 6 minus the square root of 13 on 6. All right, so we've got that plus and minus. So they're our two roots for the quadratic 3x squared plus 7x plus 3 equals 0. All right, hopefully that is cleared up how to use the quadratic formula, where it comes from. If you have any questions, leave them below in the comment section. I'll get to them. And yeah, we'll see you next time. Thanks, guys.